Good day, guys. You are welcome back to ID International Academic Mathematics class. I want to believe you enjoyed the last class. Today is going to be enjoyable as well. Let's move to the simplification of exponential expressions. Here we want to learn how to put in use the different laws of indices we have learned. Example number 1. Simplify 8 raised to the power 7 over 3 times 27 raised to the power 4 over 3 divided by 9 times 16. This is 2 raised to the power 3. We express the 8 in index form as 2 raised to the power 3 times 7 over 3 that was there before times 3 raised to the power 3, that is 27, times 4 over 3, that is there in the power region before, that has been there. So 9 is 3 squared and 16 is 2 raised to the power 4. 16 could be expressed as 4 raised to the power 2 or 2 raised to the power 4. Either of them will give you 16 at the end of the day. But here I decide to use 2 because I have observed that 2 has been the paramount root that I see here. 2 and 3, they are the current root, paramount roots in use here. That's why I use root 2 as in base number 2. So 3 we cut 3 here to have 2 raised to the power 7 times this 3 also we cut 3 to have 3 raised to the power 4 divided by 2 raised to the power 4 times 3 raised to the power 2. Don't forget, I told you the other time that if you have b raised to the power x over b raised to the power y, the result is b raised to the power x. Sign of power y here is positive, so it will be negative here. Also, if you have b raised to the power x over b raised to the power minus y, the final answer there will be b raised to the power x plus y, because the sign of power of b at the denominator will turn to the opposite to match with the power of the one in the numerator. So don't always forget this, please. According to that, this will give us 2 raised to the power 7 minus 4 times 3 raised to the power 4 minus 2. Do you understand? 2 raised to the power 7 will be operated with 2 raised to the power 4. So that is 2 raised to the power 7 divided by 2 raised to the power 4. It gives you 2 raised to the power 7 minus 4. 3 raised to the power 4 divided by 3 raised to the power 2 gives 3 raised to the power 4 minus 2. 2 raised to the power 7 minus 4 gives 3 times 3 raised to the power 4 minus 2. 4 minus 2 is 2. 3 raised to the power 2. So, 2 raised to the power 3 is 8 times 3 raised to the power 2 is 9. 8 times 9, that is 72. Do you understand? Example 2. Simplify 2 times 8 raised to the power x minus 1 divided by 2 raised to the power 3x plus 2. How do we go about this? Regard 2 as 2 raised to the power 1. Don't just multiply 2 and 8 together to have 16 raised to the power x minus 1. That is an aberration because they don't have the same formats. 8 is having power x minus 1. 2 is having only power 1. They are not in conformity at all. So 2 cannot multiply this to give 16. Not at all. So you express 2 as 2 raised to the power 1 times the 8 also as 2 raised to the power 3 into x minus 1 divided by 2 raised to the power 3x plus 2. So this will mean you now remember the first law that we discussed when we started, in which we learned that multiplication changes to addition and we take one of the common base to carry the powers operated on it. So we have 2 raised to power 1 plus 3x minus 3. What I have done here is I've simply opened this bracket with 3. 3 times x is 3x. 3 times minus 1 is minus 3. And this addition is as a result of change in this multiplication to addition. And that will be shifted to the power area to be operated. Divided by 2 raised to power 3x plus 2. 2 raised to power 1 plus 3x minus 3 is 3x minus 2. Divided by 2 raised to power 3x plus 2. What we need to do now is to remember that if you have b raised to power x divided by b raised to power y, it will be equal to b raised to power x minus y. Remember. So also 2 raised to power 3x minus 2 will be minus, open the bracket, 3x plus 2. So this is 2 raised to power 3x minus 2. Use the minus here to open the bracket. That gives minus 3x minus 2. 2 raised to power 3x minus 3x gives 0. Minus 2 minus 2, that is minus 4. This could be your answer if it is in theory. But in objective, you may not see it like this, and you may. You check the options very well. It may be 1 over 2 raised to power 4, which is 1 over 16. That is it. Example 3. Simplify 8 over 27 in bracket raised to power 2 over 3 times 1 over 3 divided by 2 whole number 1 over 4 in bracket raised to power minus 1. To start with, 8 over 27 could be raised in power, each of them, the numerator and the denominator. So as 2 raised to power 3, that is for 8. For 27, 3 raised to power 3. Everything raised to power 2 over 3 times 1 over 3. Divided by 4 times 2 gives 8. Plus 1, that's 9 over 4. Raised to power minus 1. Looking at this, you can see that power 3 is common to the numerator and the denominator. So you have 2 over 3 raised to power 3 that is common to them times 2 over 3 times 1 over 3 divided by 4 over 9. Remember this law of negative index. 9 over 4 will turn upside down to become 4 over 9, and the negativity with the power will disappear. So instead of negative 1 as power, what remains now is 1. But because it is 1, I don't need to repeat it to write it. And if you write it, it does nothing there. So 3 here, we cut 3. So we have 2 over 3 raised to power 2 times 1 over 3 divided by, instead of this division line, I use division symbol to write 4 over 9. So 2 raised to power 2 is 4. 3 raised to power 2 is 9 times 1 over 3 times 9 over 4. Do you understand? This division sign will turn to multiplication, and the divisor, that is 4 over 9, will turn to 9 over 4. The inverse of division is multiplication. Once you put it there, then you find the inverse of the divisor. So 9, we take care of 9. 4, take care of 4. The result is 1 over 3. The simplified form of all these is 1 over 3. Example 4, simplify 1 over 3 in brackets raised to power 2x plus 1 divided by 1 over 9 in brackets raised to power x minus 1. So 1 over 3 raised to power 2x plus 1 divided by 1 squared over 3 squared. You express each of the components in index form. To simplify it, raised to power x minus 1. That means 1 over 3 raised to power 2x plus 1 is divided by, this is 1 over 3. Because power 2 is common to them, bring it up, times x minus 1. So this is simply 1 over 3 raised to power 2x plus 1. This division sign changes to subtraction in the exponential area. That is minus. Open the bracket. You now put this power there, which is 2x minus 2. When you open this bracket with 2, 2 times x is 2x. 2 times minus 1 is minus 2. But this minus, this negative sign here, is as a result of the division sign here, which changes to subtraction, which is one of the rules of indices. So 1 over 3 in brackets is raised to power 2x plus 1. Use this minus to open the bracket. Negative 1 multiplies by 2x gives you minus 2x. Minus times minus 2 is plus 2. In simplifying this, you have 1 over 3 raised to power 2x minus 2x cancel out each other to give you 0. 1 plus 2, that gives 3. Finally here, this is 1 raised to power 3 over 3 raised to power 3. 1 raised to power 3 is 1. 3 raised to power 3 is 27. 27 is the simplified form of this expression. Do we understand? Good. Example 5. Simplify 27 raised to power 2n plus 1 times 1 over 9 all raised to power n divided by 81 raised to power 1 plus n. Simple thing. The same procedure. Express 27 in index form. That is 3 raised to power 3 into 2n plus 1 times express 1 over 9 in index form. Remember, this is what we learned at the beginning, how to express fractions in index form. So this is 3 raised to power minus 2, then the power n that has been there before, put. Do you understand? Divided by 3 raised to power 4 into 1 plus n. So opening this bracket with 3, we have 3 raised to power 6n plus 3 times 3 raised to power minus 2n divided by 3 raised to power 4 plus 4n. Applying the laws of indices here, take one of the common base, which is 3. You now have 6n plus 3. In the place of multiplication, you write addition in the power area. Addition minus 2n. In the place of division, you write subtraction in the power area. Open the bracket, 4 plus 4n. This line constitutes power of number 3. So you have 3 raised to power 6n plus 3 plus times minus minus 2n. Use this minus to open this bracket to have minus 4 minus 4n. Minus times 4 minus 4. Minus times positive 4n. That is negative 4n. This is 3 raised to power 6n minus 2n minus 4n means minus 6n. So, minus 6n. Don't forget we have this positive 6n. The minus 2n minus 4n is negative 6n. Plus 3 minus 4. So we have 3 raised to power negative 1. How? 6n minus 6n gives 0. 3 minus 4 gives negative 1 as the power. Now, writing it as a number of positive index, you have 1 over 3. That is the end of that. So far so good, we have been able to trash the concept indices, the laws of indices as far as expressions are concerned. In the next class, we'll move to equation, indica equation, equations that have to do with indices. But today, we have been able to trash all that has to do with expressions in indices. Before I leave you, as usual, I cannot leave you without assignments. I want to give you some assignments, some questions as assignment to lay your hands on while you are alone. Before I say bye-bye, I have this for you as your assignment for the day. Try your hands on these 4 questions on what you have been taught so far. When we meet in the next class, we have the solution together and you see where you are coming up, where you need to adjust. Thank you very much. Till we meet in the next class. Bye.